Okay. All right. Next up, we'll be looking at the integral of cos squared x. So this is again sort of a high level question, but integration has a few defined properties which we can go ahead and use for this integral. So I'm just gonna write a few of them down just for a reminder. So question 5 is integral of cos squared x dx. So firstly, what is the integral of cos x? So the integral of cos x is actually equal to sin x plus c. C is a constant term. We get that because an integral is nothing but an antiderivative. So if I were to take a derivative of this side, I would get cos x, and c can be any number. Similarly, one property which we would need to get from cos squared x to a cos function is the property for cos 2x. We know that 2 cos squared x is actually equal to 2 cos x plus 1. So we can get started with that almost right away. So if we plug this in over here, our question changes and it comes to integral of 2 cos x plus 1 divided by 2 dx. Now, since it's being whole divided by 2, I can go ahead and split it further. So this will become cos x plus, okay, my apologies, I made a slight error here. So this is actually cos 2x. So let me change this. So this is cos 2x, and then this is also cos 2x. Okay, so that is because if we look at from here, this is cos 2x. Apologize for the error, I hope you understand. So now that we have substituted cos squared x in the form of cos 2x, we can continue writing our expression down here. So this becomes cos 2x plus 1 over 2 dx. Okay, I think this is also coming by mistake. This is only on the left hand side. So we're left with, okay, perfect. Now we're back on track. So another property which we should be aware of is if I have an integral of a function of x plus another function of x, so f of x and then g of x, we can write this as the integral of the sum of those. So this would be the same thing as plus integral of g of x dx. Okay, keeping that in mind, we can go ahead and do that for our expression above. So our expression was already quite simplified. We would have cos 2x over 2 plus 1 over 2. So we can say that the 1 over 2 can come out of this expression. So we'll get 1 over 2 cos 2x dx plus 1 over 2 again comes out. We are only left with dx term. Okay, and then when we go ahead and integrate these, so we already know that the integral of cos x is sin x, but we have the term cos 2x here. So we can do this with the method of substitution. So we know if we set 2x is equals to u and we take the derivative of both sides, we would be left with 2 dx is equals to du, or dx is equals to du over 2. We can use these to substitute it in the expression here. So if I do the substitution, I will get 1 over 2 to the outside, cos of 2x, which now becomes u, and then dx, which now becomes du divided by 2, and then plus 1 over 2 integral of dx. So now this is in a standard form. We should not have any problem integrating it, and again the 2 can come out of the integral as well if you want. So our final answer here becomes 1 over 4 integral of cos x, or cos u is sine u, plus 1 over 2, and the integral of dx is just x itself. Again, since we want our final answer in terms of x and not u, we can substitute back. We know that we set 2x equal to u, so if I substitute back, I will be left with 1 over 4 sine of 2x plus 1 over 2x plus c, which is the constant of integration. Okay, I hope the solution was clear. I did make a few errors here with the identity, but other than that, I hope everything made sense. Let's see what the solution is described. So 2 cos squared x, perfect. So these are the identities we used. And we integrate both sides. This is the rule, perfect. And then we do the substitution, that's also correct. So our final answer is the exact same. So the solution is correct.